Hi all, welcome to the next topic of Unit 1, Shift Micro Operations. Coming to the contents, we're going to see the introduction and types of shift operations and in detail about each type of operation, the logical shift, circular shift, arithmetic shift and the hardware implementation of shift micro operations. Coming to the introduction, so the shift micro operations, as we know, the micro operations are used to perform operations on the data which is stored in the registers, whereas the shift micro operations are used for serial transfer of data between the registers. So the contents of the registers, they can be shifted either towards the left or towards the right. So we call it, if it is shifted towards the left, we call it as a shift left operation. If it is towards the right, we call it as a shift right operation. So during the shift left operation, the serial input transfers a bit into the rightmost position. And during the shift right operation, the serial input transfers a bit into the leftmost position. So this is the types of shift operations. Coming to the types of shifts, there are basically three types of shift operations called logical shift, circular shift, and arithmetic shift. So let us see in detail about these type of shift operations. So if you see the tabular column for the shift operations, the first two operations are with respect to a logical shift operations, logical shift right and logical shift left. The first one is a logical shift left and shift right. And the second two are with respect to a circular operations, circular shift operations. So this is circular left shift CIL and circular right shift CIR. And the last two is with respect to arithmetic shift operations. So the first one is arithmetic shift left operation represented by ASHL and arithmetic shift right operation. So if you look at this, all the operations are done on a common register R. And after performing a shift operation, the result are again stored in the same register R. So let us see in detail about each type of shift operations. First, coming to a logical shift operation, a logical shift is one that transfers 0 through the serial input. So the symbols that are used for a logical shift operations are shift left, SHL for shift left and SHR for shift right. The micro operations specify a 1-bit shift to the left of the contents of the register R in case of a shift left operation, and 1-bit shift to the right of the contents of register R in case of a shift right operation. And the bit which is transferred to the end position through the serial input is assumed to be the bit 0. Whatever type of shift it is, whether it is a left shift or a right shift, the serial input that we are using is a bit 0. So in case of logical shift, we will first see logical shift operations. In case of a logical left shift, we are going to move each bit of the register to the left one by one. And the empty significant bit LSB is filled with a 0. And the most significant bit is going to be rejected. In case of a right shift operation, we are going to move each bit of a register towards the right one by one, and the LSB bit is rejected and empty MSB bit is filled with 0. So if you see the difference between the both, in case of a left shift operation, the empty least significant bit will be filled with a 0, which is nothing but your serial input, and most significant bit is going to be rejected. But in case of a logical right shift, where the least significant bit is going to be rejected and the empty most significant bit is filled with a 0, which is nothing but your serial input. So if you look at a diagram, you will understand it in a better manner. So this is a logical shift operation. So consider this is the contents of my register that I want to perform a shift left operation. So the first bit, the 0th bit is considered as a LSB and this end of the register is considered as a MSB. So when I am performing a logical left shift operation, the entire contents of the register are shifted from this end towards the left. So this one takes the zeroth position, the one which is present at zeroth position will be moved to the first position. So after shifting, so this 1 will come here, 0 will come here, 1 will come here, 0 will come here, and the most significant bit will be discarded or rejected. But and this place will be empty. So this is filled with a serial input 0, which is inserted here. So this is a logical left shift. Coming to a logical right shift operation, from this end, from MSB, we are going to shift towards the right. So this 1 will come here, 0 will come here, 1 will come here, 0 will come here, whereas the LSB bit will be discarded or rejected. And this empty position will be filled with the serial input. This is a logical right shift operation. Next, coming to a circular shift operation. So the circular shift operation is also called as a rotate operation. It is going to circulate the bits of the register around the two ends without any loss of information. And there are two types of circular shift operations. One is a circular left shift represented by CIL, and other is a circular right shift represented by CIR. So in case of a circular left shift operation, each bit in the register is shifted to the left one by one, and after shifting, the LSB becomes empty. So the value of MSB is filled in there. So in case of a logical shift operations, we are discarding one bit. So and we are adding one serial input. But in case of a circular shift operation, there is no discarding of the bits in the register. The bits remains the same, but the positions of the bits will vary. So you are going to circulate the contents of your register. In case of a circular right shift operation, each bit in the register is shifted to the right one by one. After shifting, the MSB becomes empty. So the value of LSB is filled there. So here, if you see an example, you will understand it better. So this is the contents of my register. So this is circular left shift. So in case of circular left shift, from the left, I am going from here LSB, I am going to shift it towards the left. So 1 will become here, come here, 0 will come here, this 1 bit will be come here, 0 will come here, and this bit will not be discarded. This will be replaced with this particular empty position of LSB bit of the destination register. So this is called circular left shift. So if you see here, there is no loss of information, but we are only just changing the positions of the bits. In case of a circular right shift operation, the contents of the register will be first shifted towards the right. So 1 will come here, 0 will come here, 1 will come here, this 0 will be here, and this bit will not be rejected or discarded. It will be just replaced with this empty position available here. This is called as a circular right shift. You are performing a circular operation or a rotate operation on the contents of your register. Next, coming to an arithmetic shift operation. So arithmetic shift operation is a micro operation that shifts a signed binary number to the left or to the right. So arithmetic shift multiplies in case of a shift left, it multiplies a signed binary number by 2. In case of a shift right, it divides the number by 2. So arithmetic shift must leave the sign bit unchanged because the sign of the number remains the same when it is multiplied or divided. Whatever it is, the sign remains the same. But in case of a left shift operation, you are going to multiply the sign number by 2. In case of a right shift operation, you are going to divide the number by 2. Coming to different types of arithmetic shift operations. In case of arithmetic left shift, it is similar to your logical left shift. There is no change. Only the change is with respect to arithmetic right shift. So in arithmetic left shift, the similar to your logical left shift, each bit is moved towards the left, and the empty least significant bit is filled with a 0, which is a serial input, and most significant bit will be discarded or rejected. So this is similar to your logical left shift. In case of an arithmetic right shift, there is a change. So each bit is moved to the right one by one, and the least significant bit is rejected, and most significant bit is filled with the value of previous MSB. So if you see an example, this is a shift, arithmetic left shift, which is same as a logical left shift, where we are moving the contents towards the left. 1 1 0 0 1 1 0. This bit will be discarded. This bit will be discarded, and you are going to replace this empty with a serial input 0. Okay. Next, coming to arithmetic right shift, you are going to first move the contents of the register towards the right. So 1 0 1 0, and this one is going to be discarded or rejected. And this empty bit, empty position, you are going to replace the same value. So this one will come in two positions, two bit positions, here and here. So this is arithmetic right shift, and this LSB bit will be discarded. So that is the difference between arithmetic left shift and arithmetic right shift. Arithmetic left shift is same as a logical left shift. Remember that. And arithmetic right shift, there is a change. It is not similar to logical right shift. Next, coming to the hardware implementation of shift microoperations, this can be implemented by means of a combinational circuit shifter. This can be constructed by means of a multiplexer. So, this is a 4-bit combinational circuit shifter, which is constructed using 4 multiplexers, and there are 4 inputs A0, A1, A2, and A3, which are given as an input to the multiplexers. So apart from this, we have serial input, one for the right shift operation and one for the left shift operation. So the serial input at the right shift is represented by IR, which is nothing but 0. The bit is 0. So we are representing as 0. And the serial input at for a left shift operation is also going to be added here. So all these are connected. Apart from this, we have a selection input, select S, which takes a value of either 0 or 1. So for 0, for performing a shift right operation, it is 0. For performing a shift left operation, it is 1. So whenever the selection input S is 0, it means that the contents of the register will be shifted towards the right. So when they are shifted towards the right, so the bits will be shifted down. So initially say this 0, 1, 2, 3. So what happens? The 0th bit will take this place as output of H1. So if you see here, the function table, uh, A0, A1, A2, A3 are the contents of the register. So if it is a shift right operation, the A0 will be given as an output to H1, where A1 is given as an output to H2. A2 will be given as an output to H3. So this position will be empty, H0. So we are this will be filled with a serial input, which is 0. In case of a shift left operation, when a selection input S is equal to 1, so A1 will be at a H0 output, A2 will be the H1 output, A3 will be the output of H2, and here we are going, this bit will be discarded, so it has to be filled with a serial input. So IL. So this is a hardware implementation of a shift of micro operations. So there are two serial inputs, one for the shift left operation and other for the shift right operation. When the selection input S is equal to 0, the input data is shifted right, which means towards down. And when S is equal to 1, the input data is shifted towards the left, which is shifted up in the diagram. So based on this function table, this hardware implementation works. Thank you.